Oh, good a time as any. Hi, everybody. Welcome to Chemistry 140. This is your instructor speaking. Ooh, through the power of the internet. I'm waving my hands. You can't tell, though, because I don't have a webcam. This is our first lecture. And I didn't even update what we're really doing in there because I forgot to. So let me do that real quick. So use the chat feature to say hello. Yeah, that's good. We could still do that. Today we're doing syllabus and unit 1. So professional. I should have had this all done earlier. For whatever reason, my throat is really itchy, so I'm going to be doing a lot, and I apologize for that. This is why it's important to stay hydrated. So I hope everybody has some water, because we're going to get started right now. For some reason, that didn't capture that. Hold on. Is anything happening on that screen? No, it's not. Not at all. Okay, that's strange. PowerPoint, I want you to capture that. Is that what I want? Ooh, this is no good. Hold on. That's also not what I want. Hold on just a second here. So this is the problem with having a setup that works. Okay, so that worked. But for whatever reason when I advance this it doesn't work. Oh god. This is not a problem that I foresaw. Crap. Okay. I might have a serious issue here. Well, this is obnoxious. So I've been doing this for several quarters, and OBS is perfectly fine with capturing it. Can I do it this way? Oh, that might have worked. Did that work? It did. Okay. All right. So we're just going to do the intro again real quick. There we go. I apologize for that. Apparently, I had to tell it to do compatibility for Windows 10, which is new to me because I just installed Windows 10 because I am a technical Luddite, apparently. I don't know. I was using Windows 7 forever. Okay, so you should be able to see what's on my screen now, which includes my name. And I can see that it's showing up there, so I know that it's working. I apologize for that. I assumed it would work. This is why technology is bad. No, technology is fantastic. I'm just bad. Hi, my name's Wes Hillman. I will be your instructor for the fall 2021 term here at Everett Community College for Chemistry 140. Feel free to address me as any of the following, either in chat or in email or whatever. So Wes is fine. You don't have to call me Hillman anything, or like don't call me Mr. Hillman. It makes me feel old. You can call me Professor. I had a student who started calling me Boss, and I was like, I'm going to add that to the list. And then I am like waist deep in Dungeons and Dragons and Shadowrun and all that stuff. So any denomination of orc is fine. Mr. Orc. That's why I have that icon in Discord, if you've seen that. How do you get a hold of me? So normally I say this is the fastest way, is just email me. But honestly, if you Discord frequently, you know how to use the @ function to contact another person. You could just type the @ symbol and then start typing Professor Wes and then any message, and it will make a sound on my end, although I might have that muted. But like I see the pop-up on my screen because I always have your Discord channel it's open in a window on my second monitor. And as long as I'm not teaching, I will look over there within like 10 minutes and be like, oh yeah, there's something important that I should look at, unless I'm like grading or whatever. So Discord is probably the fastest way to get a hold of me, but this email is the second fastest. When you use this email, and this is the part where I try the other thing, which I also didn't test because I assumed it would work. Let's see if this works. So this goes through Gmail. Or your EVCC account. You can use Canvas if you want to. But Canvas is a lot slower, particularly at the start of the quarter. Like today, if you try and send me a message through Canvas, it might take 5 to 10 minutes for it to send because Canvas is just overwhelmed by every other instructor doing something. Gmail pretty much sends stuff almost immediately. So if you need to get a hold of me because it's late and you're trying to like go to bed in the next hour and you need a reply, I mean I'm a night owl, so I keep my email open and I check it all the time. So if you want to get a hold of me, just send a direct email. Don't go through Canvas or use Discord. You've probably looked at the schedule and seen something like this. So you've seen that the classes are Monday, Tuesday, Wednesday, 2:30 to 4:30. Usually, on the Wednesday class, we will have office hour. This week, there is no office hour because we haven't learned anything yet. There's not really much to go over. But starting from week 2 onward, all of our Wednesday classes are going to be office hour periods, starting at 2:30. If you have questions, please bring them to office hour. If they are like long questions that I can't answer over email, or Discord, I am happy to answer those live during a class because what I have here is this screen here, and then I actually have to click on it over here so that I can access it. And so, like, if you had a question, I could put it on the screen here so that you can see it. And then now we could be like, okay, so I want to convert, I don't know, 45 feet to centimeters. And then we could start doing the calculation. And so on and so forth, right? And then when I don't want that, I can just go, and it's gone. So this is my whiteboard. I'm going to be drawing all over it. So I have this available, and it's easy for me to use, provided that we're streaming. So if I'm trying to email you, I can copy and paste stuff. It is probably easier to just see me doing this stuff live. So bring those questions that require me to do written work to office hour on Wednesday, and that's when I'll go over them. Hopefully by now everybody has logged into Canvas. Are my office hours exclusively on YouTube? I try to do standard office hours at 2:30 to 4:30 only on YouTube. If you have other office hours that you need me to, or like if you have questions at other times, if you send me a message on Discord, Discord's a lot better because it will keep a log of everything forever. So I can just copy and paste my work from Photoshop, which is what I'm using, into Discord and just have a written record in your Discord chat. I prefer not to use video chat because it's kind of choppy. But I will do voice call on Discord because Discord does voice really well. Yeah. Hopefully by now everybody has logged into Canvas at some point. If not, we're going to do that really quickly just to show you where all the syllabus stuff is. I don't know which window this is going to open in. Here we go. And then I have to go over here. And we want a window capture. And I want... which... Oh, it's this one, right? Yeah, there we go. Boop. That's a little too big. Hold on. That's probably good. Okay, so you should be able to see Canvas now on the screen. So this is what my Canvas looks like. It's pretty similar to what yours looks like, except I have a bunch of just like administrator stuff up here. But you should have a course somewhere in there that either says Chem 140 2536 or Chem 140 2537, depending on which course you are. And these colors are hideous, so they will be blue. So I'm gonna just make them blue. There you go. So I'm just gonna click on one of them. And you're going to end up on a page that looks something like this. And then you have all of these other options down the side. You won't see any of these that have this line through this eyeball. These are just admin stuff. So like this is where all the files for the course are kept. And there are a lot of them because I am a mess when it comes to organizing files. What you're going to want to do is you're going to use these first few tabs up here. Announcements is just a record of all of the stuff that we have done so far. Modules is the meat and potatoes of Canvas. This is where everything is. Note that if you have not done the orientation quiz, the rest of this stuff down here, and there's a lot of it, won't appear. And that you want to do, first thing, do the orientation quiz as soon as you can, so that you have access to all this stuff, including the slides and the lab documentation and stuff like that. We're going to use the syllabus in just a second, but the rest of this stuff, if you haven't signed up for Discord, make sure that you jump in there. I think at least half of the class is in the Discord channel. It is a community so that you can just like type messages, the messages stay there. It's basically a really fancy bulletin board. Back in my day, we had to use bulletin boards and discussion posts. I don't even have, like... Normally, I'm like, here's the discussion channel page. No one's going to use this shit, right? Like, that's what Discord is for. Discord has made that obsolete. So, if you don't like Discord or you don't want to use it, that's fine. It's optional. But do seriously consider using it because it is a very valuable resource for many students. And you're missing out if you don't. So, I have a link to online student tutoring. There's also a link over here for e-tutoring if you need any help beyond me. We have an excellent chemistry tutor at Everett Community College. Her name is Candace. She's in charge of all of the chemistry-related tutoring center stuff, and she comes highly recommended. In fact, sometimes she teaches classes for our department when we have some available for her. Down here, after you've unlocked the orientation quiz stuff, you're going to see a bunch of lab things. We're not going to worry about lab until week 2, so we'll get to that next week. And then down here are all all unit 1 through 16. We're going to do 16 different topics in this class, although some of them do get paired together because of their length, so units 4 and 5 are together. On every module, you're going to see a list of recommended readings. So if you click on this, I have a bunch of linked pages and a bunch of videos that I will be showing you in the lectures that I have linked on here, just in case like you wanted to watch them again. So like when we start unit 1, we're gonna show some experiments with sodium, potassium, rubidium, and cesium. I'm gonna show you this video about gravity, which will certainly get my video copyright struck because it's a BBC video, whatever, it's for education, and so on and so forth. So clicking on all of these things brings up, like, this is basically the textbook. I don't know why these images are broken. I will have to look into that. Could just be a Canvas thing, I don't know. But this is basically your online textbook. A lot of these will link to something called the OER, Open Educational Resource textbook, Adam's First Chemistry, on OpenStax. That's the textbook that you use in 161, so I've sort of pointed you towards that textbook because you're going to be using it next quarter anyway. So a lot of these recommended readings point towards that. Beyond recommended reading, I have the slides. So this is what we're going to do today. We're going to do Unit 1. So you could have this handy if you want, or you can download it right here and have a file available, and then you can print it and do whatever you want to, etc. And then finally, I have a worksheet, and it's key. Oops. Hold on. Oh, for fuck's sake, come on. This is just, it's going to move. I'm not going to click. I've learned my lesson. There we go. So I have a worksheet for every chapter where I ask you to do certain things. So, like, chapter 1 is all, like, definitions and what is science, etc., blah, blah, blah. These are the types of questions that you will see on assessments, so quizzes and exams. Doing the worksheets is sort of like your homework for the class, although there is other homework recommended in the recommended reading. And then after you have done the exercises on the worksheet, you can look at the key. Now I'm clicking on it, nothing's happening. And anything in blue is my definition or answer for the question. Okay. If you have questions about any of the worksheet questions, let me know over Canvas or email or Discord. Any of those methods is fine as long as I get your message so I can help you. Later on, you're going to see quizzes pop up. That's going to be in the quizzes tab. And these are all the quizzes that you're going to take this quarter. When they're available, you can click on them and it will take you to a separate thing. This is actually not what you're going to see. You're going to see something a little bit different than that. This is just what I set to build it. You'll notice that on every quiz there will be a due date. And when I say due, what I really mean more is like D-O, due. So, due them by this date. As I type it in the chat because spelling and English and whatever. So, when you see a date that says due, make sure that you do the assignment by that time. You're going to hear that referred to as what's called a soft deadline in most things like the syllabus and whatever. The assignment's hard deadline, or the closing date, is 24 hours after the due date. So, the orientation quiz I just leave open forever, but I prefer that you do it by the due date. Because I'm not going to lock you out of the course materials forever. But every other assignment will have a due date and then a closing date. All assignments have to be done by the closing date. The due date is just sort of like your 24-hour last call notice to like, okay, I got to do this if the due date is passed. Canvas will mark it late. I don't care if you turn in stuff after the due date, but you have to turn it in before the close date. I don't open up assignments for you to do after the close date for any reason. And then finally, if you click on grades, I'm not going to actually click on grades here. Because it will show everybody's name in the class, and that's a FERPA violation. But if you click on grades, it will show your grade in the class and all of your scores for all of your assignments. So far, the only thing that's in the gradebook is the orientation quiz. I do need to manually release your grades, so if you take a quiz and you're like, where's my score? It's because I haven't gotten all the scores yet, and I had to hit a button, and that'll post everybody's scores. So that's the Canvas primer. That's how we use Canvas for all of our stuff. So let me know if you have any questions on how Canvas works. Happy to go over it with you. I know that sometimes students have difficulty trying to log into Canvas because it's weird the first few times. If you have any trouble with that, make sure that you reset your password. If you still have trouble, contact the IT help desk or e-learning, and they will direct you to the correct person. If you don't know those addresses, I can get them for you. That's fine. Before we go over the syllabus, I have a short little bit on methodologies and strategies that we have done actual research for from previous students who have taken 140. We have taken surveys from students like, hey, what are the things that you did that were effective? We've taken course evaluations, and we compiled all this information over many years, and this is the feedback that we've gotten from, by and large, the most students. What are the things that you did that you felt helped you be successful in Chem 140? And number one thing that came up a lot, hey, that textbook that we bought, or that textbook that's the OER, or whatever, the source material that I provide for you, looking over that at first is confusing. But then when you go over it in the lecture, it makes a lot more sense. So reading the textbook first may not clear everything up, obviously, because if you could just read the textbook and learn the material, I wouldn't have a job, right? But having that foundation helps you a lot, so that when I come in and give you the lecture, I can fill in all of the cracks in the foundation with, I was going to say cement, but knowledge sounds like a better analogy. I don't know. So reading the textbook definitely has its benefit, and it's probably best to do it before the lecture. You can read it again after. It's not a vegetable. It doesn't go bad. So you can do that whenever. Number two, if you have questions, bringing them to my attention while we're doing the content is very, very relevant. Obviously, if I talk about something and you're like, oh, that's the answer to my question, then you're good. But if you're sitting there waiting for me to clarify on something and you don't see that and you ask me that question, then we can get to that topic in the context of the current discussion, and that might help you or even other students. So bring any questions you have to the lecture, and then ask them at the appropriate time when we go over something, or ask for clarification or whatever. Also, make sure you have the slides, because the slides are what is going to be shown on the screen when the screen works. It's working now, so that's good. And then draw all over the slides. That's probably the best thing to do. That's my advice, is to use all the materials that I give you and just like completely obliterate them. Like draw pictures all over them. Doodle if that helps you focus. Like do whatever. Use them however you see fit. I don't care. Make them into origami. Then take a picture and put it in the Discord. That would make me happy. Homework in this class is optional. However, it is strongly recommended because you don't learn anything by just watching me do it. That would be the same as saying, oh, I want to learn how to be really good at Olympic swimming. So I'm going to watch I want to learn how to swim really well. So I'm going to watch somebody do it in the Olympics. I'm going to watch it on the TV and be like, oh, I see how they did that. Okay, great. You're not an expert by any means by just watching somebody do something. Like, you don't become good at tennis by watching Serena Williams. Like, she has put in so much goddamn practice that you can learn from watching her, but you certainly couldn't execute at the same level of her ability. And the reason that she is able to get to that level of ability is because she practices. Homework is your practice for the material that you're going to cover in these lectures. And so if you are looking at a topic on the lectures and you're like, oh, this seems easy, and then you come back to it for the quiz and you haven't like prepared or done anything with it, odds are you're going to forget and be like, oh, shit, I don't remember how to do this after all. And then you're kind of hosed because you're taking the quiz. So make sure you're doing as many homework exercises as you can. Whether you are doing them by yourself or in a group, if you are participating in any way, you're benefiting from it. So make sure that you are just trying to immerse yourself in the material as much as you can. And then finally, ask me any questions that you have. Come to office hour. Use the chat. Use the Discord. Use email. Use all the resources. That's really what I'm trying to say here is, if you treat this like an online class where this is the only time you hear my voice or see me talk or whatever, and you completely ignore all the other resources, you're going to have a bad time. All right. There was a question that was asked, when do you have to submit the worksheets? Those will be assigned formally starting week 2. There is a lab every 2 weeks or so. I'll get to that when I get into the lab stuff starting next week. And we'll mention that a little bit of that on the syllabus, which we're going to put on the screen in just a second here. The last bit of institutional research that we have for you is how there's a question on our idea/evaluation things that you do at the end of the quarter. And well, there's 2 questions, actually. The first question is, how many hours per week did you spend preparing for this course in any capacity? So did you read the textbook? Did you do homework? Did you talk to people about chemistry? Did you watch YouTube about various topics? Everything except for the lecture time here. What time outside of this 2-hour period, 2 times a week, did you spend on chemistry? And the most common answer that we got from students was this: 14 hours a week. And you'll notice that that's just to get a C. That was the other question we got, or we asked, was, what grade do you think you got? So Most students are actually pretty accurate at predicting their grades because you could check your grade on Canvas. But that's a lot of work. I don't think anybody's going to come into this class and be like, yeah, I want a C. C's make degrees. That's something a senior says, and this is your first year, right? Your spirit hasn't been hopelessly crushed yet. But the reality is that learning stuff is hard. And then we sort of take that for granted. When you get to my age, 37, and you're like, man, I have to learn something, there's a lot of inertia there. You don't want to learn something because that takes a lot of effort and mental gymnastics and stuff like that. So you have to put in enough time to become proficient at anything. And this sort of just correlates to what I said before. Make sure that you are doing the homework exercises, reading the textbook, taking notes, writing flashcards, doing whatever, etc. Now, depending on your study habits or your aptitude or your situation, you may need more or less time than 14 hours. If you are what I would call gifted, I guess I would say. That's the word that was thrown about when I was in elementary school, was we had the gifted and talented program for honors students or whatever. And you just like pick up things like you're a sponge to absorb knowledge, then you might need less than 14 hours a week. That is perfectly reasonable. Don't try and meet an arbitrary number because I said so. Try and evaluate what works for you. If you can do material and you're like, man, this is so easy, I know this, congratulations, you've learned stuff. But if you're doing questions from like the worksheet or from the online text or whatever, and you're like, man, I have to keep looking up stuff in my notes, then obviously that means that you need more preparation. Your goal is to be able to, and I gotta find my cursor here. Where did my cursor go? Oh, that's not what I meant to do. Hold on. Where is my cursor? There it is. So your goal is to do the practice problems. There we go. I'm writing in a really awkward way. Like I'm writing to the right of me. In fact, you know what I should do? I should just put the tablet in my lap here. Do the practice problems without the use of your notes. Okay? That's your goal. If you... Oh, part of my W disappeared there. There we go. If you can do the problems without having to refer to your notes, you can easily get a C or better. In fact, you probably get an A. In fact, as you're going to learn very quickly when I get to the syllabus, you're allowed to use your notes for anything that you want to. Because I can't stop you. It's an online class, right? If you have a lot of stuff going on... I see these questions in the chat, so I'll get to them in just a second. If you have a lot going on, for instance, somebody asked, how many credits do you think is too many? If you are a first-time student and you've never done college before, 12 is the limit of what I would recommend. That is, of course, the minimum for financial aid. So a lot of people take 12. When I started college myself, my first quarter I took 16. And 16 was a lot, but I was one of those high aptitude students that I barely had to study. And that worked great for me my first year, and then I hit a wall. And I was like, wow, now I have to suddenly study, and I didn't know how to study. So I wish I knew all of this stuff then. So definitely study, but I was one of those students that, like, I basically just took all the classes that I could. So I took 16 my first quarter, and I was not working. I did not have a job. And I was living on... this was at UC Irvine. I went to University of California. And I did not have any other prior commitments for my time beyond being a student. So, of those 12 to 16 credits that I would say is safe for a first quarter student, Chem 140 is 5. Now, that basically means that this is going to be 40% or so of the time that you spend for college this quarter. Yeah, 15 is probably okay. What you don't want to do is what I did, which was I took 25 my second quarter, and I basically died. I somehow got through that, but every minute I was just going to lecture because I had 5 classes, and it was insane. Don't do that. But there are a lot of things that eat up your time. So if you are working is the big one. I mean, it's currently still a pandemic, right? So you have all that stress to deal with on top of a job, and then you have this class. The other big one would be like taking care of family. Um, or like you have kids and you have to see them off to school, or maybe like you're homeschooling them or something like that because the classroom, I don't know if the classroom is a safe place. Like none of that is going to be stuff that you could just like boop, okay, that's done, let's go focus on Chem 140. Like those are all activities that take up a lot of time, right? And that time's got to come from somewhere. And given the choice between one, feed your kids, two, sleep, three, study for Chem 140, and four, job. Job and kids are always going to be the ones that take priority, and the other two, sleep and Chem 140, are going to be the ones you cut. And of those two, Chem 140 is probably the lower priority than sleep, right? So I realize what the pecking order is for people because I live that life too, right? Like, if I'm doing all these things, learning takes kind of a backseat. And especially right now when we're all like, our mental health is taxed to the limit because of the pandemic. So my warning to you, which is why I have this all in red down here, is that because this is a 5-credit course, make sure that you are not taking too many other credits. If you think you are, like you've got 16 to 20 credits and you're working a 40-hour job at Amazon or something like that, talk to me if you're concerned and we can try and figure something out, because advising is going to just recommend that you sign up because, I mean, the college needs to make money, right? That's part of the reason is like we make money off tuition so that we can fund other classes and stuff like that. So a lot of the incentive is not necessarily in the student's best interest, in my opinion. But I'm your instructor. I have your money already. I might as well give you good advice, right? Like, I'm salaried. I'm going to paid whether you take the class or not. So I'm going to try and advise you to do what I think is best for you. Because I've done this for 11 years, and I've seen many students succeed, and then I've seen other students not be as successful. And it's not because they can't do it. It's because of time. Time is your big enemy in college. It's finding enough time to put in enough practice for mastery. Okay, so make sure that you have enough time to commit to this class before continuing, because you definitely don't want to be in a situation where it's like week 7 or 8 and you don't know how to continue because you just haven't had enough time to practice. I'm getting the syllabus on the screen. We'll go through this real quick, but I do need to window capture real quick. Let's see here. Is it this? It is this. So, boop. You don't need this stuff on the side. In fact, if I do that, I can make it a little bigger. All right. There was one more question. How do we know when we should be finished reading a section in the textbook? In the recommended reading, I have the sections delineated by read this thing or read these pages. If you go through all of those in a section, you'll be up to date. If you're wondering what we're going to be doing during that day, if I scroll all the way to the end, we're going to get to this at the end anyway. You can see what we're doing. So like today we're going to do the scientific method, chapter 1. We're going to do unit 2 on Wednesday and then again on Monday, unit 3, and then so on and so forth. So before Wednesday, I would have looked at least units 1 and 2. Just a brief cursory look is fine. Like, you don't have to read it in crazy detail. Just read over it. Like, don't spend more than an hour or 2 reading per day because you'll just get sick of it. But like an hour would be fine. And then note like, oh, I don't know what sig figs are. I should make a note of that and ask him. So, because that's what we're going to do on Wednesday. We're going to talk about what significant figures are and so on and so forth. So you can read a lot of this on your own. Very important right off the bat, if you are in the nursing program, you're in the wrong class. You want Chem 121. Chem 140 is for engineers, biologists, chemists, pre-med, stuff like that. So if you're trying to get into majors chem or bio, Chem 140 is where you want to be. If you are trying to get into the nursing program or allied health or radiology or dental hygiene or stuff like that, I believe dental hygiene is 121 also. But the other three that I listed are definitely 121. So again, if you're confused and not sure, let me know. I will advise you to go to the right spot. Just to look up your intended major and I'll be able to do that. Hey, you need internet. Make sure that you have internet. So obviously, so that's a required material is the internet. If you're watching this later on like a mobile device or something, make sure you have enough data. If you are not sure where to get like a Chromebook or something, if you go to your student portal right here at this link, and you can make a request for one. You can also email the IT help desk or the library. All of those will point you in the right direction. So those emails are on the screen for you to use. Something that I do want to mention is that I have to list a required text as part of the syllabus, but the textbook that we're using is an OER text online, which is all those links and stuff that I gave you. It's not perfect because it's OER. That's why it's free, is because somebody put it together on their time. And there will be mistakes in terms of like broken links or whatever. If you have issues with it, let me know. I can try and edit stuff. There may be just issues from like copying, or maybe the pictures just don't exist. Like, more or less focus on the text. And if there are other issues, I can try and figure them out as the need arises. Are the notes in the recommended textbook more useful or the PowerPoint slides? So the PowerPoint slides are what I'm going to use to facilitate our lecture discussion. Personally, I would say that the slides are better, but I'm very biased because I made them. Whereas the OER textbook, I don't know who made that. I think it was another faculty member at the college. What do I want to talk about for the... Oh, it's down here. Okay. If you have gone to the bookstore website, you've probably noticed that if you enrolled in Chem 140 for Samita's section, she's Dr. Singh, she had a textbook that was required. I have this textbook that's optional, and it's the same textbook. And the reason for that is because I'm not doing the labs out of her book. This is the optional book. Okay, so this is what we're going to talk about. The optional book is really, really, really good for more worksheets. There are so many practice problems in the general chem prep book that, like, if you are doing my worksheets and you're like, man, I need more practice, do you have any more exercises? I'm going to point you right to that book. That does require you to either order it and have it shipped to you or go to the Everett Community College bookstore. But the college is open, so that's not so difficult now. But the number of practice problems in that book is super, super high. I would strongly recommend that if you get in a situation where you're like, I just need more practice, go to the bookstore and buy that. Try and do that before like the first few weeks, because I don't know if they keep these in the bookstore forever. But it is a good resource if you want more practice. If you need a calculator... yes, I do want to open this webpage. And you have never used an online calculator, this is the one that I recommend. Trying to get it on the screen here. There we go. So this is Wolfram Alpha. And Wolfram Alpha will basically do whatever you want to do with it. So, for example, maybe I wanted to find sine of x plus cosine of x equals 4. And I wanted to plot that on a graph. Now, that's just a circle, I think. Oh, maybe not. I don't know. I'm just typing in random shit, so... Like, it will graph things, it will tell you other forms for it. Or maybe you have a system of equations. So you have like 30.84x plus 15.9y equals 108 9.9. And you have 7x minus 14y equals 30. I don't know. Solve this system of equations for me. Bang, there it is. It's done. So you can use this for virtually anything that you want, that we would need it in this class. If you have a TI-83, obviously, by all means use that. But don't use Windows Calculator. It's garbo. Don't use your phone's mobile calculator. It's garbo. Use Wolfram Alpha because it has scientific functions on here. In 161, you're going to be using the natural log function a lot, and you're also going to be using the log function a lot. And this will do those, no problem. Other calculators might not have that functionality. There's the square root button, and so on and so forth. So if you don't know a command or how to type it in there, you can always message me, and I will fix that for you and help you. Only downside to Wolfram Alpha is that the mascot, which is this guy right here, is super creepy. And now you can't unsee him. That's going to be real fun for me next time I open a web page with that link, because I'm going to open it and I'm just going to get like zoomed in on crap because I'm dumb. Oh yeah, Desmos is the other one that's really good. I think Desmos has a little bit more of a learning curve. Like, I have it on my phone, and I find it frustrating to use. What is this that I've clicked on here? Oh, uh-oh. I might have broken something. That's okay. The last link that I recommend right here is ptable. You can click on that, and in fact, I'm going to put these links in the chat here. So wolframalpha.com is an online calculator, because you can't click on my video. And then ptable is an online periodic table. So you can copy and paste this in there. I just want to get through the rest of this in the next 10 minutes because we're going to take a break in a second. This is just the schedule. Typically, we're going to lecture on Monday and Tuesday. I didn't lecture on Monday yesterday because it's the first lecture. And I don't want you guys to come into this blind and not know how YouTube works. So we played Mega Man 5. It was fun. You can go watch that if you want. I mean, obviously you should probably be studying, but there are some weeks that we will study, or not study, but we will schedule them differently, and that's for. Oh, hi, Nika. The reason for that is because of things like holidays. So, Veterans Day, I think this year falls on a Friday, so that doesn't affect us. But Thanksgiving, normally, we don't have class on Wednesday, so there won't be like anything that week. If there was a Monday or Tuesday lecture, this is why I schedule 3 days. So, we don't use all 3 days for lectures. So the third day will be review or office hour or whatever. You could read all of this. Really, the only thing that I care about in the YouTube guidelines is, like, don't be an ass. So, like, hate speech, slurs, spam, etc. Absolute no. I will immediately ban you. I can't show how to do that on here. I guess I could ban my former student here, so I'd be like, haha, no. I'm just kidding. Just kidding, Nika. But yeah, I can click on a thing. I guess I can't ban myself, and completely remove all your messages and squelch it from the chat. And I have had to do that before, not for students because these lectures are technically public. But if you are disruptive and cause problems or say things that are hurtful or inconsiderate of others, I do take action. That's the one thing that I am very, very strict about, is don't treat people like shit. Like, there's enough of that out beyond the classroom. Like, let's all be civil and friendly here. We'll have a lecture tomorrow, yeah. So we'll always have 2 lectures per week. So tomorrow there will be a lecture, and we'll do Unit 2. And that's all on the calendar at the end of this. Attendance is not mandatory. I don't take attendance. So all of these videos are archived. If you can't make it to lecture, you don't have to email me saying I can't make a lecture, because that's okay. I've structured the class excuse me, so that you don't have to worry about making these 2-hour live streams. It's sort of a hybrid online/live stream. Homework we've already talked about. We've talked a little bit about quizzes. The way that quizzes open for this class is that when we finish the content for a quiz, I open the relevant quiz for that unit. So the first quiz is units 1 and 2. So when we finish unit 2, the first quiz will open, and you have a week to do it. Then I set the due date, and then the close by date is 1 day after that due date. Okay. Quizzes are multiple choice, free response, fill in the blank. They take on the same form as the orientation activity. So you will see various question types, most of which you have already seen in the orientation quiz. The questions do come up at one at a time, but there are some gimmicks to it. And those gimmicks are, one, it's timed. You get at least 30 minutes. If quizzes have calculations or stuff that requires a lot of time to write stuff down, I give you a little extra time. The time limit gets a little less lenient as the quarter goes on, and then on the final exam, you have to gun it. You have to know the material, because you will run out of time if you don't. And if you stop to look up stuff at any point, your time keeps ticking down. So the quiz starts when you hit go, and it does not stop until you hit done. Now, you'll notice here, and this is really important because I think a lot of other instructors frown upon this, but I personally think that this is up to you. This is an online class. I can't stop you from looking up the answers online. The only thing I can do is put a bunch of hurdles in your way to make it really, really inconvenient, right? So, if I put the candy in a bin at the bottom of the ocean and say, you can have the candy, it's right there, that putting it in a bin at the bottom of the ocean is probably going to dissuade you from getting the candy, right? Likewise, I'm sure that there are answers to similar, but not necessarily my questions, because they're randomized and I edit them all the time. So don't bother looking at my questions on Chegg or whatever, because I've tried and it's too difficult. And if you spend more than 2 or 3 minutes trying to find something and you don't find it, you've wasted a lot of time. So you can use any resources that you want for the quiz, but mind the time limit, okay? If you run out of time, the quiz immediately ends and is scored, okay? Now, you do get 2 attempts per quiz. I take the better of your 2 scores, and your final score is whichever of your quizzes you did better on. Usually, people do better on the second attempt because they have seen the question types. Not necessarily the questions, though, because the questions are randomized. I have a pool of, on a 10-question quiz, I have a pool of 25 questions. Maybe 5 of this type, and 3 of this type, and 2 of this type, and whatever. And I pull X number from each pool, and then there's your quiz. If you try and communicate with other people, you might have different questions than them. And if there are numbers involved, I guarantee they will be different because the numbers, I have 200 different solutions. And I just tell it, pick one. And so your numbers will always be different from any other students. So collaboration is not really frowned upon in this class, but it might not help you. In fact, it may hurt you for doing the quiz. So my recommendation is, 1, know the material because you did the practice problems, and then 2, work on it on your own with as few distractions as you can. Now, if you have a technical issue and your quiz blanks out, or Canvas crashes, or the power goes out, or whatever, that counts as one of your attempts, so be mindful of that. So I don't give you a second attempt for any reason. Make sure that if you have an issue, you wait for that issue to resolve before taking your second attempt. So if you're taking your quiz during a thunderstorm, probably not good if the power goes out and then comes back on. Don't start the second quiz. Wait until the thunderstorm's over. Now, obviously, if you're waiting up until the very end of the deadline, you might not have a choice there. But no extra attempts for any reason, so just fair warning. what else was I going to say about the quizzes? Oh, all of your quizzes are randomized, not only in questions that are given, but also the order that you get them in. And also, you only have one question on the screen at a time, and you may not backtrack. Okay? So you answer a question, and if you don't know how to do it, you have to go to the next one or type in some answer. What's the question of the time limit ratio? Like, I would say that it starts fairly lenient, and then it tightens up pretty quick by the end of the quarter. I know last quarter a lot of people were like, "Holy shit! How are you supposed to do the final exam that quickly?" And yet I looked at the average time that people were taking; it was less than the maximum amount of time. So I'm not certain that those complaints were warranted, but I definitely saw those complaints. And I've structured it for that reason. Like, I want you to start with a generous window, and then I will slowly constrain that because, again, I'm trying to get your knowledge on this, and if I give you infinite time, I don't have an accurate assessment. Last thing about the quiz is that your score and the answer key is released, but only after the quiz closes, and I've graded all the quizzes. Okay, so when you finish the quiz, you're going to get a window that says, "Thank you, you've done the quiz." And you'll be like, how do I know what I did? How do I know my score? Well, you don't. How do I know if I have to take the quiz again? Well, you don't. You have to go on your own intuition and your gut feeling, like, oh, did I do well? I should take the quiz. Or I don't have to take the quiz again. Oh, I don't think I did very well. I should take the quiz a second time. Or just take the quiz twice always. All of those rules that I just outlined for quizzes also apply to exams. Exams are just longer and they're on certain dates. There are 2 exams. And the final is longest, and it's at the very end. The only differences between the exams final and the quizzes is that I never release the key for the exams. So you don't get to see how you did on those, because that's not the point of the exams. The exam is how I assess you. The quiz is how you assess you. So I look at the exams strictly to see, have you learned the material? If so, you get a good score. And then that's it. It's kind of like the SAT. You don't get to see your answers for the SAT. You just get a score, right? This is how that functions. And the final exam is the same way. We're going to talk about the lab next week. Again, for late work and stuff, after a closing deadline, it's closed. It's done, and I don't open it again for any reason. Make sure you get everything done by the closing deadline. If you miss 5 or more things in this class, or you miss the final, I can't give you a score. It shows up on your transcript as either V or E. Not E, sorry, F. We don't use E anymore. Now, all of those things and restrictions and stuff are waived for one instance. This is what's called the NQA policy. Because it's a pandemic, because everybody has a bad day or week or whatever at times, like, you get overwhelmed, totally reasonable. I get overwhelmed all the time. I get it. If you have an issue that comes up that prohibits you from turning in something on time or doing something on a date or whatever, you get 1 NQA. No questions asked. I will break one of the rules and let you fix an issue that you have. Generally speaking, because it's an online class, that's going to be a due date. So for any assignment, except exams or the final, because I got to get scores out to people, I just cancel the deadline. And as long as you turn it in by the end of the quarter, I will score it and give you credit for it. This is most commonly used on labs because labs require a little bit more work and timing, and they're more open-ended because it's a worksheet you're filling out. So if you're just like, man, I'm overworked and this lab is due tomorrow and I haven't started it, I'm going to use the NQA and just worry about it later. That's what it's for. You get 1 of those, and then I put it in the gradebook. This just shows you how the points are broken down for this class. I will try to stay as close to this as I can. 72% is the minimum for a C. 92% is the minimum for an A. Again, you can check your score at any time on Canvas. There are a small amount of extra credit points on exams in the final. No extra credit is offered otherwise. You could calculate your grade by, it's just a simple formula. How many points have you earned? How many points are possible times 100%. Canvas should be pretty accurate about this until we start putting in exam extra credit. Then it might goof a little bit. And I think the rest of this is just stuff that you can read on your own. I think the last day to withdraw for a full refund is next Monday, so week 2. The last day to withdraw without my permission is week 8. I don't give grades of N or I or V unless I absolutely have to for some reason. I is a very weird condition. If you like disappear and you would have passed the class if you had done X, Y, or Z, I give you an I. V is like something very serious happened. Like if you caught COVID in week 7, I would give you a V. Because like you should rest and recover. Excuse me. If you have CDS accommodations, I have already gotten an email. I don't know if I've set that up yet. I think I tried and it didn't let me because I hadn't actually published the course. Let me know if you have any questions about that. If you need accommodations, make sure that you email CDS and get that set up as soon as possible. It doesn't apply retroactively. It's proactive. So any time modifications or conditions or whatever will get applied from that point to the future. So the earlier you get that to me to get that set up, the better. And then finally, you get out of this what you put in. So do everything that you can to make the most of the resources and the materials that I give you. And then finally, here's the schedule. Let me zoom this out a little bit. Oops. It's not Alt. There we go. So there is the schedule. You'll notice that on most of the Wednesdays are just Q&A sessions, so those are office hours. Some of these say extra lecture. If we fall behind, I will use it as an extra lecture. Anything in blue is an important deadline or due date. And some of these due dates do fall off of the schedule. So, like, exam number 1 is going to be on a Friday. Exam number 2 is on a Friday, and then the final exam is on a Wednesday. So just be mindful of that. So you do need these Fridays available. I can move the exam date 1 day forward or backward for you if it helps you. Email me if that's an issue. And then, yeah, so that's the schedule. So, yeah, so the only homework that you're turning in is the lab worksheets. You don't turn in actual written homework because I don't know how you'd send it to me. I guess you'd scan it and upload it. But I only collect the lab worksheets from you. The quizzes and exams go through Canvas. Approximate number of problems per quiz. That's really hard for me to answer because something that's like open-ended or like topic discussion has fewer questions, whereas things with... Or actually, no, those have more questions. Things that are math tend to have fewer questions because I can get a lot out of one problem. I tend to ask you lots of little questions so that you don't have like, oh, it's an 80-point exam. Here's 10 points on a question. Oh, you got it wrong, minus 10 points. Because Canvas is all or nothing most of the time. So I ask you a lot of little questions. So if you don't know the answer to a question, you're like, man, I've spent 2 or 3 minutes on this. Just skip it. Go to the next question. Do I have a favorite chemical? Not really. I like all of them. That's why I studied chemistry. And you have to let me know what assignment for the NQA. No, what you need to do is you need to email me before it's due. And then say, like, hey, I'm not going to turn this in on time. Can I NQA it? Or I need more time for quiz number 3. Can I NQA it? And then I will hit a button that will extend your deadline. And if I don't hit the button, you have nowhere to turn it in, obviously, because the assignment will be closed. So you have to let me know so that I can hit that button. It says in the syllabus you have to do it beforehand, but really, if you're just close to when it's due, don't surprise me at the end of the quarter with like, hey, I'm turning in lab 1 with my NQA. I'll be like, why didn't you message me? Because I need that information. All right, that's the syllabus. You can look up all of anything else that you care to by downloading it off of Canvas. Now, this is a 2-hour lecture, and I don't do 2 hours at a time. Normally, we would take our break a little bit earlier, like at 3:20. But what I do is I hit this button, and it starts a timer, and when that clock says 10 minutes, we come back and we start lecture again. So until then, go get some water, go pet a cat. I don't know, do anything, right? It's your time. So I'll see you in a bit. Oh, he went away. Okay. As soon as I hit the timer, the cat went away. Let me pan the music out here real quick. Boop. And then go like this. And oh, we don't need this anymore, so is that what this is? Yeah, there we go. Alright, welcome back. Hopefully you got to pet a cat and get more water. I got more water right here. What do we got today? We have... Well, it's either raspberry lime or regular lime. Those are the two flavors I have in the fridge, so... Raspberry lime. I brought this out an hour ago, and it has since warmed up a little bit, and I'm kind of sad about that, because I thought I was going to open it earlier, but... Alright. So, in each of my slides per unit, I have a table of contents, and you're going to see these, like, dark slides peppered out throughout the thing that separate the sections. And the blue line is the section that we're looking at. So for this section right here, oops, where'd my pen go? So this is Unit 1 that we're looking at, and these slides will concern... I'm going to have to tilt this a little bit, aren't I? I'm still trying to figure out a good setup here for... This will work, I think. For how this is going to work, but... So the first thing that we're going to talk about is, what is science? Like, you're taking a science class. What does that mean? And we're going to talk about that definition and a little bit more here. So, science is basically something people say when they don't necessarily understand what's going on. Like, you might just say, oh, it's science! I missed when I said science. Oh, these are different icons. Hold on. Oh, okay, there we go. Ah! I'm still getting familiar with this setup here. There we go. So you might hear people exclaim the word science, or they might even misuse the word science. Now, regardless of what major you have, you're going to have to take some amount of science credit. So if you are taking this class as an elective because you're a humanities major or a like journalism major or accounting or whatever, maybe they told you to sign up for Chem 140, and that's a good choice because this is one of the easier electives for Chem for science. If you are a scientist, which means you're going into the field of science, you're going to need to know what science is. So, science is the study of phenomenon that occur and our attempts to explain them. And so what we do is we look at stuff that's going on around us, and we say, there's a lot of interesting things happening here. We're going to establish this as a science. So, for example, people might look at rocks and be like, how do rocks form? Where did they come from? What are they made of? And then that becomes a science, and that's geology. Or they might say, look at the weather. What are clouds? Where do clouds come from? What is this water falling from the sky? And then now you have meteorology or environmental science and stuff like that. So we can categorize all sorts of different things in the sciences. Now, each of these different disciplines is going to be a field or a major that you could dedicate your entire life to studying. Here are some examples at the bottom here. Of course, the one that we care about the most is this one. Well, it's the one I care about the most. You might not. What is chemistry? Chemistry is the study of matter, so the stuff that you are made of, and all the stuff around you, and what that matter does when it encounters other matter. For example, if you were to pour hydrochloric acid on your desk, what would happen? Ideally, the answer is nothing, because we've chosen a matter to make your desk out of that is resistant to corrosion. Now, if you made your desk out of sodium, I can't help you. But knowing how different matter behaves helps us do all sorts of things. For instance, if you are going into biology, knowing what elements are important for nutrition, which provide energy for cells, and which ones are toxic is rather important. And we cover a lot of that in chemistry. Like, why is this atom so bad for you? Well, it makes multiple bonds to this other atom, which is abundant in your body. That would be bad. We're going to talk about that sort of just on a case-by-case basis as things come up and we talk about them in various topics. Now, how do you science? In theory, studying science is very, very simple. And it basically starts by just asking a question. What is this thing? I don't get it. I don't understand why this is doing that. And so you start doing research. Research is just inquiry into a given question that you don't know the answer to. For example, you might be like, why does this flower grow in these conditions? So that would be your question. And then you could start testing things. Like, okay, well, what if I gave it more water? What if I gave it less water? What if I gave it more sun? What if I gave it less sun? What if I gave it salt? What if I gave it sugar? What if I yelled at it for 30 minutes every day? Like, there are all sorts of different things that you could do to try and answer this question. And you can eliminate a lot of possibilities by just doing one of those questions. So if something thrives by giving it lots of water, giving it no water probably is going to have the opposite effect. You should still do the experiment to be sure, but every time you do something, you start to generate knowledge about your topic and you start to answer those questions. So we're going to categorize research into different subcategories here. The first category is basic research. What is basic research? Basic research, oh my goodness. Let's try that again. I'm trying to get used to this setup here. There we go. Research. Basic research focuses on fundamental ideas. The simplest, most elementary concepts behind a question. So this would be like, oh, how do atoms bond to each other? As opposed to, how do atoms form your body? Like, that's a very complex question, right? Like, you've quintillions of atoms in your body. In order to understand how they all got to where they actually are, we need to talk about how any two get to where they are. And so we'll start with the most basic question that we can. How do you bond two things together? Now, you could ask other questions along this nature, like, why is the sky blue? Or, why does grass smell like it does when it gets cut? Like, these are very simple questions that can be answered. Actually, the grass question might be a little more complicated. That might dive into the applied field a little bit more. Applied science, and again, this is going to be my test. Can I underline something? There we go. You know, I am going to just set this pad on my lap. Give me a second here. Let's see here. Hello. Okay. Yeah, that feels a lot better. I'm just going to write on my lap here. Goodbye. Okay. So applied scientific research is the application of the very basic ideas that we got to more complex topics. So if I did basic research and learned, oh, okay, I can bond these two atoms together. Your application of that could be, how do I use the things I make out of this? So if I can bond carbon and hydrogen together, what can I use carbon and hydrogen containing products for? Oh, it turns out they're explosive. I will use them as fuel. Oh, it turns out that they have a low boiling point. I can use them as a coolant, I guess. I don't know, something like that. So these topics down here are just slightly more complicated. So, like, how do I use lithium metal in a battery? Why is lithium metal the best choice? How do I make more happy molecules in the brain? So dopamine and serotonin. How do I get people to feel better about everything? We could all use a little more dopamine and serotonin, right? I want to make a rocket. I want to get the hell off of this planet. How do I do that? What can I make my rocket out of? Should I make it out of magnesium? No, because magnesium is soft, and if it catches on fire, it will light up like a sparkler. Probably good to know, right? Don't make your rocket out of magnesium. That would be bad. Now, once you have finished all of this, and there's a reason that I have Civ 6 on the screen here. Once you have done your applied science and you know, oh, okay, aluminum is a really good material for rockets because it's lightweight and it's sturdy. So I'm going to do that. I'm going to make my rocket out of this material. The result that you get out of that process is called technology. Now, on the board here, I have various technologies that, like, you might not think of printing as a technology as much as, like, the printing press was a technology. But printing was this revolutionary thing. Oh, instead of handwriting stuff out, I could just put a bunch of, like, characters into a thing and then go stamp, and then get another piece of paper and stamp. And now I'm just making multiple copies of these super fast. That revolutionized stuff. And was super important. So printing, just the concept of it, was a technology. You could say the same thing of things like agriculture. So when people realized, hey, you know what would be easier than like foraging for food in the wilderness? What if we grew all the food in one spot? Like, that's an idea that came up. Somebody came up with that. They started doing that, and it revolutionized civilization. And then other things, so like plastic communication with radio, Wi-Fi, satellite, rocketry, computers. Computers are a huge element of technology. All of these different things. So like if you can think of it as like a thing and point at it, it's probably technology. Like you can't really point at how do atoms bond. Like you could point at a bond, but like I can point at this aluminum can on my desk, and the aluminum can has been engineered in a very specific way so that you can stack them efficiently so they don't collapse on themselves. And they can hold pressurized gases that have dissolved into a liquid. So the aluminum can would be a form of technology. And so science follows this sort of tiered process. You start at the bottom with basic research to understand ideas behind any basic thing. And then what you try and do is you say, okay, how are those ideas useful? How do I apply what I've learned in the basic research? I've made this catalyst that decomposes plastic. How do I get that out in the ocean so that I can remove the plastic from the ocean? That would be the applied research. And then the technology would be the device you sell to people who want to clean the ocean of plastic. And then if you're playing Civ, you launch the space shuttle and you win the game. Hooray. Okay, that's great and all. Those are very simple definitions, but how do you do this? Like, what is the method by which we actually understand stuff? Because there's a lot of knowledge in the world, but the means by which that knowledge is acquired can be suspect. For example, this is going to be a really relevant thing. How much do you know about vaccines? Where did you get your knowledge? Did you get it from the World Health Organization? Or did you trust Uncle Johnny Barfowitz, who linked an article about horse dewormer? One of those has been iteratively researched repeatedly, and the other is Uncle Johnny Barfowitz, who probably found it from someone else and reblogged it. I don't know. One of those is not very scientific. Which one is it? Now, all science, regardless of where it comes from, whether it comes from Facebook or from renowned and peer-reviewed and accredited institutions, actually comes from guesswork, believe it or not. So don't take this out of context, but the first idea for the COVID vaccine came from, well, what if we tried this, right? We know that COVID has proteins, it has spike proteins on its exterior. What if we tried to make a protein that made those proteins, which is what the mRNA vaccine does, and then we injected it into cells, which then produced that protein, and then the body attacked it because they thought that it was a foreign invader? Maybe that would work. And that's actually how the mRNA, the Moderna and the Pfizer vaccines work, is they make a protein that is on the surface of COVID viral shells. Your body sees the vaccine protein and goes, oh, this is not supposed to be in the body. I now know to look out for this thing. And then if you get exposed to COVID, your body already knows, oh, I saw that protein in the demo. We're going to get rid of that now. And then your COVID experience is much less awful. So that project started with a prediction or an educated guess. And then what they did was they did experiments. Okay, if I make this and I administer it to people in clinical trials, does it do what we think it does? And then finally they record results. Oh, hey, this seems to be working very well. But can we make it better? And so you then refine your results based on what you've learned from the previous trial. And you do this iteratively. You do it again and again and again and again and again until you get the vaccine. And so this is called the scientific method. The scientific method... Oh, I got to find the highlighter here. Hold on. There it is. So the scientific method is the circular, iterative approach to studying a topic. Now, I'm picking vaccines because it's relevant. But you could do this with anything. So maybe you wanted to ask a question about gravity. Like, let's try and understand gravity. Let's put ourselves in the shoes of Isaac Newton. Can we figure out how gravity works using the scientific method? Well, we could start with some sort of test. So I could say, okay, I'm going to just drop things. And then you would see what happens. So we're going to actually look at this in a second. And then you might try and drop other things. You'll notice that, like, oh, if I drop, like, feathers versus a bowling ball, they don't fall the same at all. What's causing that? Is it the weight of the bowling ball? Bowling balls are heavier than feathers. Can you think of a circumstance where you could definitively answer that question and then design an experiment to test that? And then take your results and make future predictions. We're going to walk through all of that after we define all these terms. So I'm going to just put these terms on the board here. So the first term that we care about is the hypothesis. This is your prediction of what you think might happen. And this could be based off of prior knowledge. So for instance, you might think, okay, I have eaten carrots, which are high in fiber, and celery is very similar to carrots because it grows in a similar way. Perhaps this will also be a source of fiber. And then you eat the celery, and it turns out celery is delicious, or you might think celery is disgusting. But you could at least predict that, oh, okay, I bet chemistry. I bet carrots and celery have the same impact on your body. Whereas carrots and, say, hamburger would have different effects on your body because they're vastly different. They're produced in very different ways. And so you're making these predictions without actually doing the experiment because you haven't actually eaten these things. Based on prior knowledge. Oh, I know where carrots come from. You pull them out of the ground. Oh, I know where a hamburger comes from. You go buy it at the store after grinding up a cow. Those are very different. I bet they'll do different things to my body. Now, in order to test that, you have to do the experiment. Your experiment is a scenario or setup that is very, very controlled. And there's another word that I want to put here that isn't actually written here. Reproducible. When you do an experiment, you should get the same outcome every time. And that's very important. If you do an experiment and you get random results, then you can't really learn something. Like if I bounce a ball on the floor and it bounces back up into my hand the first time, but then I drop it the second time and it just goes and like splats on the ground. And I drop it a third time and it explodes into 60 billion little pieces. I don't know what it's going to do the fourth time, right? I haven't learned anything other than anything could happen, which is more or less where I started. But if I drop a ball and it always bounces every time, then I would learn from that experiment, oh, the ball will bounce. And I would know that because I have made an observation that states that. I did this experiment 8 times, and every single time, the ball bounced. Every single time I plant these carrot seeds, I grew carrots. Every time I pet the cat, it purrs. Like, these are all observations. And so you learn that, okay, if I do this thing, this is the outcome I will experience. Now, when we talk about these observations, we can categorize them using 2 different adjectives. So the first adjective I'm going to assign is qualitative. Qualitative observations describe qualities, so things that you can ascribe to something else that basically just give more definition to its qualities. What does it say in red? Oh, right here, sorry. That says reproducible results. My pen is not super great. I can rewrite that. So you can probably see the word results there. You can see that I'm moving the pen here, and like the letters are appearing one at a time. And I think it's just PowerPoint being silly. So reproducible just means, can you get the same outcome over and over and over? I wish I had a text tool that I could just add to on these slides, but I don't. So here are some examples of qualitative observations. Like, what qualities can you measure of, say, I'm looking around for something that isn't my soda, or my, not soda, but seltzer water here. I have a little statue of Roadhog from Overwatch on my desk here. And, like, if I had to ascribe qualities to him, I would say his belly is round. He is wearing a mask that is rubber. And he is spiky. Like, those are all things that I say where you could be like, oh, yeah, I can imagine that. So, like, if I said, oh, my desk is really cold right now because there's a fan blowing on it, you would know that my desk is not going to give me a 3rd-degree burn. So, like, these are observations that help me describe something in general detail. Now, if I wanted to be more specific, how cold is your desk? Oh, well, it's 40 degrees Fahrenheit. I'd have to ascribe a number to it. And that's where quantitative observations come in. Quantitative observations require you to measure some sort of quantity. Oops. And in order to measure a quantity, you need to use an instrument or a tool. And that's important. People do not make quantitative measurements. People can make qualitative measurements. For example, you can tell me if it's hot or cold out, but if I asked you to tell me what the temperature was, you could not do it to any degree of accuracy with, like, licking your finger and putting it in the air. You would need a thermometer to do that. Like, you could go outside and say, oh, it's about 50 out. But could you get close enough to say that it was like 56.3? No, absolutely not, right? If you were trying to weigh something, like you could pick up a bowling ball and be like, oh, that's about 14 pounds. But there's no way that you could say, oh, this is 14.21675 pounds. Because you can't do that. We don't have senses that allow us to do that. We need a tool to do that. So anything involving numbers to any degree of precision is going to be quantitative. So if you're looking at an observation and I'm asking you, is it qualitative or quantitative? Look for numbers. Anything with numbers in it that is specific is quantitative. Anything else is qualitative. Now, counting something could also be quantitative. You and I can count, so you could say, oh, there were 6 marbles in this box. That would still be a quantitative measurement. And the reason for that is because you used a tool, and the tool was counting. Now, as we start to gather all of this information together to science properly, we're going to notice that there are various results that occur for given experiments. For example, earlier I was mentioning reproducible results here. I have the wrong pen selected, sorry. My reproducible results can be interpreted as a fact. So for instance, if I get the same outcome every time, I'm going to make an assumption that it will happen in the future. We're going to treat it as a fact. Now, on the screen, I'm going to show you 3 different videos. And I have the cursor already. Okay. So let me click on this first one here. And I have to actually capture it real quick. Actually, you know what? We'll make a new window, because then I can just capture that one. Okay, so I don't need the syllabus anymore. I need sodium and water in a 40-gallon tank. And, oh, you can't see it yet, because I gotta... Let's see here. Oh, that's not even the right dimension. What am I doing? Alright. I haven't actually started the video yet. But we're going to watch this very scientific... There is audio here, so I'm going to make sure I get that. Okay. So, this is a very scientific video of somebody putting sodium in a 40-gallon tank. So, here we go. Alright, what did you observe happened? We put sodium in the trash can with a bunch of water in it, and, I mean, boom, I guess. That wasn't super exciting. Okay, that was video 1. I'm going to give you video 2. I get this warning every quarter, and I always forget that it's going to happen. Alright.
Disgusting. Disgusting.
So there's sodium. This is even more scientific.
Did you miss?
No, they're in. Didn't you hear the boom?
You doofus.
Yeah, no, it's floaties.
The longer it takes, the farther back to get. It takes a
Jeez!
Okay, so that, yeah, where is all the safety equipment? This is not OSHA safe. So there's our second experiment, and then our third one, this is actually done in a laboratory by scientists. This is sodium metal here. It's right here. You can't see it because the resolution on this video is not that great, but when we let it sit in the water, this happens. And so what our job is to take these 3 experiments, and we need to synthesize something out of them to figure out what was similar and what was different about all of these. So what can we interpret as facts here? In fact, you should be able to make one scientific fact as a statement. Sodium and water do something when they are together. What is that something? And so you can type that in the chat. So there you go. You could say something like sodium reacts vigorously. I'm Canadian, so this U is important. With water. Now, we have to be careful about what we say. So if you say, oh, it always bursts into flame, well, you didn't see any fire in the first one. We did see fire in the second and the third ones, though. So seeing it in 2 out of 3 situations definitely supports that. Now, it does burn and catch on fire. But just be careful that you aren't overstating what you know. But yeah, saying it more simply is safer and better. So when sodium reacts with water, it reacts vigorously. A word that I would use to describe that is an explosion. All right. Now, once we have done enough experiments, we might start to branch out to other elements here. So we've looked at sodium, and we have a scientific fact on our hands that sodium metal will react with water. But sodium metal is not the only element out there. There are other elements that exist. Why don't we play with some of those? So I'm going to choose some of these elements. I'm not clicked on the right thing here. There we go. And we're going to see what happens. If I just hit this, there we go. When we do these reactions. So we got potassium here. And I had to hit pause there because I forgot to put the video back up. Okay, so this is potassium. This video is a little higher resolution, so you can see this. But I want you to look at this video, remembering the sodium one that we just watched here. I want you to compare and contrast them. How are they similar and how are they different? Okay, ready? Here we go. So that was potassium, and I'll replay sodium here for you. Alright, so how were they the same, or similar, I should say? And how would they be different? Now, with regards to scientific theory, we're going to get to that definition in just a little bit. Uh-oh. There we go. Why did my video go blank? Oh, weird. It's just capturing funny. That's okay. So those are great observations. They both seem to explode. They both catch on fire. They both release energy. Now, how are they different? The potassium was much faster. So they're not exactly the same, are they? They both seem to explode on contact with water. However, one is faster than the other. So this is where we're actually going to go to get to the theory. The theory has to deal with why is this happening and what information have we gained from it. So next we're going to do rubidium. This is rubidium. I hope you enjoyed rubidium. Here it is in slow motion. It's fast, and then we're going to do cesium. So here's cesium. And it's done. That's it. That's cesium. I like that in super slow-mo, it sounds like an old Nintendo video game. Now, what are you learning about these metals that are dropped in water? So the law that you would observe is probably very obvious. What's the thing they all have in common? And so you could write that. Oops. I didn't mean to actually click forward. I meant to click on the pen. And it's going to be the same thing we wrote before, although you couldn't see it because I had the thing in the way. So these metals react vigorously, and again, this U is important because I'm Canadian, with water. And that's it. That's the law. So the law is just, what is the observation that you make for this family of things? Vigorously is subjective, yes. However, we can use subjective things because they help us give an understanding. So if I said these metals react with water, and I wrote that in a notebook, and you... Uh-oh, why is... Oh, it's Steam's disconnected. I don't care about that. If I wrote, these metals react with water, and then you did that, and you're like, oh, well, what scale is this? It must not be that big, and then it explodes in your face. That would be a problem. So it is okay to use subjective language with the intent to clarify an observation. So to summarize for this slide, when we look at scientific facts, we are looking at an individual experiment. Or a single entity. So I can get a fact about sodium. I can get a fact about potassium. I can get a fact about rubidium. Now, if I collect all of those together, then I get a law. So laws are summaries of various facts. That was meant to be an underline, not a cross out. So facts are individual things, laws are for groups of those individual things. Now, something that is very important here that we would like to describe is that all that we have done for scientific facts and laws is answer this question: how matter behaves. Now, what we have not answered is, why does the metal explode? So far, all we know is, oh, it just does, right? So if you can answer something very, very vaguely, like, oh, well, that's just what happens, what you are describing is a scientific fact or law. So where does the theory come in? And you may have heard the word theory used a lot. In fact, it seems to be misused all the time. And a reason for that misuse is from, like, popular culture happened. So, in order for us to have a scientific theory about our metals being dropped in water, we would have to understand why they explode. Now, if I drop aluminum in water, nothing happens. So obviously aluminum must be different from sodium somehow. And our question is, well, how are they different? At this point in the course, obviously we can't tell you that. In 161, though, we will answer this question. So it turns out that the electrons around atoms like sodium and cesium and rubidium and so on and so forth are very easy to remove because there's only one of them and it's far away from the nucleus. And since it's easy to remove the atoms, you get a much more vigorous reaction. As opposed to aluminum, whose electrons are closer to the nucleus and are held more tightly, and you don't get as much energy out when you put it in water because the electrons aren't removed. Now, if all of that discussion went over your head, that's totally fine, because we don't even technically know what an electron is yet in this class. But if you've heard of these words before, you can see what the difference between a theory is and a law. Theories give you nitty-gritty details. This is why this is happening. So, for example, for vaccine theory, the theory behind why the vaccine works would be it's because your body has been trained to make a template of a protein that already exists on the virus's surface, and the body then identifies it and removes it as a foreign entity, whether it's the vaccine's protein or the COVID itself. That would be the theory. The law would be vaccines lower the severity of COVID-19 infection. It's just a general statement, right? Like, I could say that without actually understanding how it is, because I can look at the data. I can look at number of vaccinated patients in the hospital versus unvaccinated. Or I could look at number of mortalities or vaccination rates or things like that. There's lots of data that I can look up that would support the scientific law that the vaccine is effective. Because those studies have been done. And then the theory would be the nitty-gritty details under it as to why this is effective. Okay? So that's the difference between theory and law. Theory is much, 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 much more in detail and explains why what we are observing is happening. All a law does is explain how. So if you hear somebody say, well, this is just a theory, that person has no idea what science is. And I'm calling out that game theory guy because I hate when theory is misused. It's just a theory, a game theory, and I think you're just an idiot, a game idiot. Because you don't know what that word means. I say that as a gamer. So, alright, so here we have an example with gravity. What is gravity? What do you know about it? You know a bunch of things about gravity, right? You've heard the story about how an apple fell on Newton's head, and then he was like, oh, gravity. Things must be attracted to the earth, and stuff like that. So, that's not a very scientific approach, though. Newton was more or less doing a thought experiment when he was sitting under this apple tree. If this even happened, I don't know if this is just a legend or what. Now, if you drop various things onto the ground, you might notice various outcomes. For example, I'm going to load this video, but I'm going to have it muted.
At the same time.
As soon as I say that, I don't hit mute in time. So let me window capture. Oh, that's the right one. Perfect. Okay, so yeah, this is definitely on the BBC. Let me expand this so that I'm just getting the video. And I'll just make this a little bigger. You know that a bowling ball is this very dense thing. And that feathers are light and fluffy, and you've probably dropped feathers before, right? Or paper, or things like that. And so you're probably thinking, oh, okay, well, it's probably has something to do with the air resistance, and that a feather has a way higher surface area, so it gets slowed down. And that's the correct answer. That would be the correct hypothesis. But Newton didn't know that. In fact, for a long time, what people thought was that things that had different masses would fall at different speeds. And then somebody did an experiment, I think it might have been Galileo, actually, where he dropped like a very heavy lead ball and a very light, like watermelon or something very light relative to it. And they both fell at the same speed, kind of like how this is going to happen. And then they hit the button, and this is the result. And there's this dramatic music that plays, and I'll hit it for a second. And like, that's so overblown. But you can see that both objects in a vacuum fall at the same speed. Now, the bowling ball is actually behind because the feathers are taller. But I bet you've never seen feathers. So, just doing those two experiments, you can already see the difference, right? Wow, everything seems to fall at the same speed. I bet air and atmospheric pressure have to do something with it. So we've learned something about gravity. Gravity is the attraction of two objects towards each other, but other things can mitigate it. If we go to the moon, which is where this video is, this is zoomed in too much now. This actually has audio.
And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather.
So you can't really see it very well. You can see the hammer in his left hand. He has a feather in his right hand. It's going to kind of pixely drop in a second here.
For our falcon. And I'll
there we
drop
go.
two of them here, and hopefully they'll hit the ground at the same time. How about that?
There you go. So that experiment was carried out on the moon. And on the moon, there is no atmosphere, so there's no air in the way. So we now have two different experiments that help us conclude that, hey, air resistance is what gets in the way and causes us to observe weird results with gravity on Earth. But all things are attracted to each other and fall to the ground at the same rate, barring air resistance. The slides are available on the course Canvas page once you've completed the orientation quiz. Make sure you get 100% or it won't unlock. Now, using that example with gravity, we can tell how gravity behaves. Things fall down, right? Now, why does that happen? Anybody know why gravity occurs? And the answer to that question is, well, if you know how gravity occurs, you should definitely let someone know, because there is no why for gravity yet. We don't know the answer to that. And that's a weird thing to say, right? Like, you feel like gravity is this very basic thing, and yet we don't know why things are attracted to each other, or what information passes between them to cause them to attract. So here's where we are with gravity. We have these two, but we don't have this one. And that's strange to say, but sometimes that's where we are. Now, we have information. So there are things like space bending and stuff like that, but like the graviton particle has been looked for ages, I think. And as far as I'm aware, it hasn't been discovered yet. So there's our summary. We use observations to generate laws and theories. Laws explain how nature behaves for a family of observations. And then theories explain why things behave how they do at a high level of detail. And to get all of these observations and experiments, we use the scientific method, which is generate a hypothesis, do the experiment, record observations, and then take our results and apply them to a new hypothesis. All right. Normally, I would have you... I'm going to just do this last section real quick. I thought there was a practice problem here, but there's not for this section. Really, the only thing that is important about the limitations of science is that science is limited by what we have observed, and so we can never define something as true. Like, we can accept something as true, but it's never absolute. So all these experiments that we do can be completely refuted by a future experiment. So be mindful of that. The information that I am going to provide you in this course is, to the best of our knowledge as a civilization, true. But is it absolutely true? Can't tell. It's not possible to know until we do the experiment and find out, like, a loophole in our theory or whatever. And thus, if that happens, what do you do? And the answer is you either modify the theory or you discard it. And so this is just a bit of philosophy, but it is a good takeaway for the first day to just, how weird is this going to get? Pretty weird. That's science. You can never prove anything true. You can only prove that it's false. We can accept that something is true, but it will never be absolutely true. And I think that that's it. Hooray. Alright, that's all I got. And that's all the time that we have anyway, because it's 4:30. So that's Unit 1. Most of the units will take longer than a lecture. Unit 2 will probably take 2 or 3 days. But that's the general gist of how the lectures will go. I will talk about a topic. If you guys have questions, you type them in the chat, which you've been doing, which is excellent. Please continue to use the chat. I realize as the quarter goes on, people start using the chat less and less and less, because they're like, oh, it's so much stuff. But keep asking me questions. There will be opportunities in the next period to actually do problems and type your answers in the chat. I will present those as problems on screen that you do, and then we will work them out together. But that's the general gist of how the lecture will go. It'll be split into 2 one-hour chunks with a 10-minute break in the middle. And that's it. That's all I got. So I do want to thank everybody for coming out to the lecture. If you have any questions, again, let me know by email, or Discord or whatever, and I will be more than happy to answer them. But until then, we will see you for the next lecture, which will be tomorrow at 2:30, where we will continue Unit 2. Take care and have a wonderful evening, and I'll see you tomorrow.